Welcome everybody to another math help video. Today, this time, on this session, we're going to do factoring special polynomials from lesson 8.7. Now, on this one, the factoring we're going to be doing will look like stuff we've seen in the past, but some of them are special cases that you're intended to see, because if you see a special case, you should be able to write the answer faster than you would than if you were working it out normally. So my goal on this one is to try and minimize how much work I have to write, because I would actually be okay if you didn't write work on some of these. So this first one, x, I'm going to write it down. We got x squared plus 10x plus 25. Now the normal thing to do is you write a big X and you say to yourself, what multiplies to make 25 on top and adds up to make 10 on bottom? I think that you could totally do that. If you don't see that this is a special case, then that's fine. I'm going to tell you right now, it's x plus 5 times x plus 5. How did I know that right away? Well, besides being a math teacher. Special case has three things you got to check for. Thing number one, is the first term something squared? So yes, x times x makes x squared. That's what starts each parenthesis. Is the last term something squared? Yes, 5 times 5 is 25. That's the end of the parenthesis. But there's one more thing you got to check, which is, does 5 times x, the two things we got as our pieces, doubled, make the middle term? Yes, 5 times x is 5x, and if I double 5x, I get 10x. And that justifies why I'm able to write x plus 5, x plus 5. Now, if you're like, what did this guy just say? You're more than welcome to write what multiplies to make 25 and adds up to make 10, and you get 5 and 5. And because there's no number up front, you don't need to bottoms up or do any box methods or whatever. You can just write the answer x plus 5, x plus 5, and be done. I'm also going to mention this. I'm going to write it right now. You can write this answer as x plus 5 squared, because if you get the same thing twice, you're allowed to write it squared. I'm going to write it the way I assume most people will when they're doing the test, and without the squared thing. But I guarantee you when I hit check, it's going to offer the... Aw, darn me. Hold on. There we go, back to this. It's going to offer me the answer that I had suggested could possibly be done, okay? Let's try that again, but with more enthusiasm. The reason why you want to look out for this special case is because problems like problem number 2 here, if you tried to do this the normal way with the x, you'd be looking at 64 times 9, which is, I don't know if I can do 64 times 586. Is that correct? 586, 40, 50, no, 576. My mistake. What multiplies to make 576 and adds up to make 48? There is an answer to that, by the way. It's 24 and 24. But who's gonna? I'm trying to be reasonable here, without being mean. How many of us students are going to recognize that? So when the numbers are exorbitantly big, then you should look at this thing and say to yourself, could this be a special case? Like, what number times itself makes 64x squared? Well, 8x times 8x makes 64x squared, right? Does something times itself make this last guy 9? Yeah, 3 times 3. But you do have to confirm it works in the middle. Is the middle thing 8x times 3 doubled? Let's put a times 2 at the end. Times 2. Is that true? This is the main thing. Yeah, the first thing is something squared. The last thing is something squared. But does the middle thing results, is that made by doing the things that were squareable doubled? Does it make 48? Yes. If that is the case, then you're allowed to write an answer of 8x plus 3, 8x plus 3. Now, on both problems so far, I haven't written any negatives. The reason why is because it's very dependent on what the middle thing is. If the middle thing is negative 48, I would have written 8x minus 3 and minus 3. But in this case, I'm going to write 8x plus 3 and plus 3. I did a lot of writing there. The goal is you don't have to write anything, hopefully. Although on the test, I would love it if you could show me that you were thinking that way. Again, I could write 8x plus 3 singularly with the squared on the outside. That's a tough case. If you don't see it, you can do it normally, but recognizing what multiplies to make 576 and adds up to 48 might be hard. My advice to you would be, If you get really big numbers, start by taking half of the bottom. Like half of 48 was 24. Try that. If it works, that means it was a special case. But you can still work it out normally. It's totally fine. All right, next problem. We got z squared minus 64. Now this is different. There's only two things. When there's only two things, you say to yourself, what makes this guy squared? That's a z. Z times z makes z squared. And what makes 64? That's an 8 squared. So the answer is going to be z and 8. But unlike the last one, which was like two of the exact same thing, the only way to get this two-parter in this special case is by writing the two things you just got, z plus 8, and then the two things you got with the opposite sign, z minus 8. These are called conjugates. By writing that, it ensures that the middle term that could have been created otherwise doesn't exist, which is what the problem shows me. There's like a missing middle term here. There's usually like a z regular term, but it didn't have that. So the only way that's possible is if you write something that's a positive and that exact same something that's a negative. So I'm going to do the next one without having to write work. So let me show you here. V squared minus 4. Oh, what times what is v squared? V. What times what is 4? 2. So v plus 2, v minus 2. It should be, on some of them, it should be that simple. Let's go to number 5. Now this is backwards and it's got a little bit bigger numbers, but it can still work. Two terms. You say to yourself, what times itself is 25? 5. What times itself is 36? X squared. 6x. So 5 plus 6x. 5 minus 6x. If you're not good at that first concept we did with those three things, that's okay. But I really encourage you to practice doing these things right here with the, what do you call it? The two-parters. Now this next two-parter, you might be looking at it thinking to yourself, wait, nothing times itself makes 50. You can't do it. Well, there's a trick to this one, and we discussed it on the same day we took this lesson because we did factoring special polynomials, and in that same lesson we learned that sometimes you got to do multiple steps. So the first step you want to take on this problem, let me write the problem down, I guess, 50z cubed minus 72z. The first step is, could I divide something out? Yeah, you can divide 50 and 72 by 2, and both these things have a z in it. So let me take 2z out. This was from an earlier assignment where you were able to take two terms and factor something out of them to the front. This leaves me with 25z squared and 36. Now, this is what's different from that assignment. On that assignment, you took something out and you were done. Here, could I factor it again? Yes, 25 is 5z, 36 is 6, so 5z plus 6, 5z minus 6. So it might be prudent for you to ask yourself, can I factor out something first, then take what the result is and split it again into something new? Yes. It seems like a lot, but it is a lot. What do you want from me? Sorry. All right. Next problem. We got 6u fifth minus 9u fourth, 15u3. Very similar situation, but with three terms. Ooh. Still do it, though. What can I divide 6 and 9 and 15 by? All divisible by 3. And I can take u to the third out. Last time I just took out z. Here I can take out u to the third because u to the third is the smallest amount of u's that any one of these things contain. So it's actually possible to remove at least u to the 3 from everything. I get 2u squared. I get minus 3u. And the last term becomes negative 5. And that's it. The u to the cube is gone. Now you got to ask yourself, can I factor what's in here further? Oof. The problem with what's in here is it's got a number out front, and to do that, I have to do something like I did on 8.6 part 2, which is draw an arrow, write a negative 10 on top, write a negative 3 on bottom. What multiplies make negative 10, but adds up to make 3. Negatives, that's 5 times negative 5 times 2. Now you got to do the bottoms up. So I do u minus 5, u plus 2. I put each of those over 2. Why am I putting them over 2? Because that was the number that was quote unquote out front. I mean, it's not literally out front like the 3u to the 3 is, but it was in front of the trinomial quadratic expression that I'm trying to factor here. All the while, 3u to the 3 is actually out front. The bottoms up method says I got to bring that up if I can't divide. So 3u to the 3. 2u minus 5. And on the second parenthesis, I can divide 2 by 2 and get plus 1. Wow, what a doozy of a problem. I gotta be honest though, that's exactly the level of like solving these I want people to be able to do. Like I want them to be able to factor something out, and then whatever's left in there, be able to factor it using regular methods. 2u minus 5u plus 1. Now, ideally, the leftover stuff will have some kind of special property you can factor, but sometimes you gotta do it the hard way, man. I'm sorry. Oh boy, look at what we got here. We got another one of them. So let's do it again. So I can divide each of these. Well, here, let me write the problem down actually. 6w6, 16w fifth, 8w fourth. I can divide everything by 2. W fourth, everything's divisible by 2. And I can take w to the fourth out of all three of them. I get 3w squared. I get minus 8w, and then I get left with plus 4 at the end. Sorry to say it, but this is like the last problem. I got to do the full Monty of a method. Now, this is not a special case. By the way, if you have 3 parts, you should always check if it's a special case. Is something times itself 3w squared? Nope. So it's not that 3-part special case we saw at the beginning of this assignment. So I get 12 on top and negative 8 on bottom, and then I say to myself what multiplies to make 12 but adds up to make negative 8. That's a negative 6 times a negative 2. So I'm going to come down here. I'm going to write w minus 6, w minus 2, doing the bottoms up method, of course. I'm putting each of those over 3. Why am I putting them over 3? Because that was the number in front of this menagerie of stuff I'm trying to factor. I get 2w to the fourth. W minus 2, because 6 divided by 3 is 2. And on the second one, can't divide, so I bring it up. 3w minus 2. Whew, so much stuff. 2w to the fourth. W minus 2. 3w minus 2. One more problem. How much time we had? 12 minutes? Oh, we're making great. Oh my gosh. I say we're making great time, and then here it is, a third one of these. Hey, you heard it from my mouth on the first problem. I said if there's one thing I want you to be able to do is factor something like this. So I'm willing to show it to you 3 times, and I hope you are willing to find time to do this 3 times. Maybe not all at once. Might take you a little bit longer than me. If you're watching this video, hopefully it's helpful. I can take out 5u squared here and be left with 3u squared minus 10u plus 7. And we're at it again. Got to do the whole thing. 3 times 7 is 21. We'll multiply to make 21, but adds up to negative 10. Negative 3 times negative 7. Almost the same thing I had here. Shall I switch it up and do the box method? Oh, for heaven's sake. Here we go. Let's do it. Let's do the box method. I got to make sure that you people that love seeing that method at least get to see it once here. 3u squared and 3u squared and 7 go in here. Those things that were connected via the large arrow I made. Negative 3u and negative 7u are going in these other ones because those were the pieces I got from my cross here. I can divide out 3u and 7. I can divide out u and nothing, so I'm going to put a 1. And then the only way to make this work, because these signs don't match up, u times 7 is not negative 7u, is to put a negative on the 7 and therefore a negative on the 1 so that it makes this stuff work out as well. So my final answer will be 5u squared, 3u minus 7, the thing I got from the side over here, and u minus 1. Does that seem slower than doing it the bottoms up way I had done on the last couple problems? A little bit. Still works. I think it's the superior way in terms of making sure it's right. But then again, to each their own. If you get it right, either way, you get it right. Holy moly! All right, we did it. We saw a few things. We saw a couple special cases. We saw 2 special cases of like a 3-parter it's called a perfect square trinomial, and it had some rules. It had the first. You know what? Let me go to the report and show you. I'm going to show you problem 2 because that was the better one. So it had three rules. Is the first term something squared? In this case, 8 times 8. Is the last thing something squared? In this case, yes, 3 times 3. And is the middle term twice their product. 8 times 3 doubled. Yes, that makes 24, and I double it makes 48. So I was allowed to write 8x plus 3, 8x plus 3, because that was the pieces that made the version less. If you're like, nope, don't get it, well, do it regular. We also saw some two-part thingies. I'm going to skip to 5. 5 was a good two-part thingy. Where it's something times itself and something times itself, and the only way to make it so that it ends up being just two things is to write conjugate 5 plus 6x, 5 minus 6x. And then on the last 3, I don't know why I made 3 of those, but hey, you know what? Those were great problems. You loved them. You had to factor something out and then factor it more. Maybe you get lucky and not have to do the whole process of arrow over and all that stuff, but you know what? You should practice a whole lot of those. You know what? I always fear I don't give enough of the same enough problem types for people to get practice on, but now that I'm seeing this, I'm thinking, heck yeah, Mr. P, you gave them 3 more times to practice that one thing, but with an extra step. So good. I'm glad I put it there actually. All right. That's that video. 8.7. I hope that was helpful. Thank you for watching these. If you watch them all the way in, weird, but cool. Thank you. You're awesome. I'll see you on the next video. Bye.